Good morning, everyone. Welcome to our series of webinars where today we're going to focus a little bit on how to put your Bullseye controller in storage mode. First, let's do a little bit of background in grain quality, which gives us a baseline for why storage mode is so important. Just a quick mention that discounts are available right now as well as financing. When we look at our products here, here at AgriDry, we are the grain quality control solutions experts. And inherent in that term solutions is that they solve problems. So when we look at our C-Flow dryer controller, it solves a problem, just like the AgriDry gravity grain spreader and the Bullseye grain temperature moisture controller. In our performance statement, AgriDry knows how to manage grain moisture and fines. Time-tested and established solutions, and we are absolutely not practicing. We have proven steps to success. Now, these two key points in maintaining long-term grain quality are extremely important, and we're going to come back to them. But the first one's going to be air always takes the path of least resistance. And second, we need to control the temperature of all the grain in the bin. So when we look at that first one, air always follows the path of least resistance. This is a pretty good example of what a big core of fines in the center looks like, and the airflow is going to go around that core of fines, so the top center is going to get out of condition. That's where our problem spots are going to be. So if we try to mitigate that by pulling that core out, by dropping that core, that's when we see that air following the path of least resistance again, where it goes straight up the center. So then the top outside is where we're going to have our quality concerns right there. So what we want to do is we want to spread those fines uniformly while we're loading the bin and get that good uniform airflow and basically selling those fines with the grain. When you look at this situation, think about how if you wrapped a piece of paper around a rock and you threw that rock, the piece of paper would fall in the middle and the rock would go to the outside. Well, that's just the same thing as what fines and grain. So what we want to do, the best long-term storage practice is to level as filling, spread the fines, don't core, and leave it alone until you're ready to ship it. That way we don't have to core, we don't have to blend, we don't have those hot spots, we don't have any of the issues. So how do we do that? We do it with the AgriDry Gravity Grain Spreader. Now this is obviously a demo model. It's going to be the 43000 series, which is good for 15 to 21 foot in diameter bins and up to 4,000 bushel an hour. Now that's not likely the case that you're going to be using, but in most situations what we're looking at, pretty much anything. But what we want to do is spread the fines as the bin is being filled. We obviously have spreaders available for up to 156 foot in diameter bins and up to 40,000 bushel an hour. Basically any application that we're looking at, we have a spreader for it. What we're really looking for with the AgriDry Gravity Grain Spreader is that good uniform spread of fines throughout the whole grain mass so we can get the good uniform airflow. Especially comes important when we're in storage mode. Here's a quick video on a 16 5000 model in a 48-foot diameter bin with a 13-inch auger. You can see you got a good overflow over the leveling band, fills the center of the bin. What goes under that leveling band goes down the chutes to the outside. It's going to rotate really slow with the gravity of the grain coming down the chutes, about 1 to 2 revolutions a minute, all driven by the gravity in the grain coming down. No belts, motors, switches, nothing to go wrong. This thing can't help but spread the fines out. And like I said, we make different spreaders for all different types of applications, and they do change as they go up in capacity, like the 40,000 bushel an hour mega spreader now available. So the big problem we run into is uneven grain moisture. So we've got really dry grain on the bottom, and this is a yellow corn example. And then we've got wet on the top. So it can be accentuated by CFM issues or cubic feet per minute airflow problems, but a lot of it comes down to running your fans at the right time. What we're really looking for, especially with yellow corn, is that good, consistent, even, uniform moisture content all the way up the bin. But we have to remember that storing grain long term is a function of moisture and temperature. So how does that factor in? On the moisture side, we have to look at humidity and its effect on grain storage. So when we're in that low humidity range, what we're going to be is we're going to have the potential to over-dry that grain. High humidity, add too much moisture. So we want to see, how can we get right in that happy middle? Well, that's where the Bullseye Controller comes in. It's going to run you right in the edge where you need to be, especially in storage mode. The other thing we have to look at is temperature. So when we have those wide outside temperature swings, we can create potential for condensation in the grain. The temperature differentials of more than 15 degrees creates a potential condensation inside the grain mass. So in this example here, this is a good springtime example. Let's say we just came out of winter. We have 35-degree grain in the middle of the bin. We've got an average of 65-degree air outside. This is an environment that would be conducive to condensation. What can happen is you have that if we don't maintain the temperature inside that bin that's easily sustainable with the outside air conditions, we can have convection currents that cause condensation on those sidewalls. And a lot of you see, this is how I kind of plan it. You look at a cold glass of water sitting on your coffee table on your deck in the middle of summer. It's going to sweat. It's the same situation with this grain bin, and that's why you see that roof drip and then the grain stuck to the sidewalls when you try to unload. This condensation can also happen if we have temperature differentials inside that bin, where we can get a potential layer of condensation in the middle, which can cause crusting and bridging and complete quality issues there. So temperature is extremely important when we're looking at this. Also comes into play on what is termed moisture migration. So on the left-hand side, this is a good fall example. So let's say we came in with warm field temp grain. We had cool air outside. So what happens, and you have to remember, warm air rises, cool air sinks, okay? So what that can do, it's the moisture holding capacity of the air and of the grain changes when it gets colder. So when it's warmer, it can hold more moisture. As that air rises, that warm air rises, it cools off on that top layer, and then it drops the moisture on that top high moisture zone right here. And then the reverse happens on the right-hand side. So in this situation, this is just like that grain in the last couple slides we had. We have that cool grain, cool air inside, warm air outside. So as it drops down, it can lose its moisture down at that bottom zone. So how do we stop this moisture migration? We need to aerate the grain. We need to change that temperature at the right times and get the right air in there, because storing grain is a function of moisture and temperature, like we said before. So when we look at this, how does that factor into what we do every day? Well, yellow corn stored at 22% moisture and 60 degrees has a shelf life of 17 days. Alternatively, yellow corn stored at 15.5% moisture and 50 degrees has a shelf life of 450 days. So what we're doing by controlling that moisture and temperature, we're actually increasing the time when we can store that grain. That's why storage mode is so important. When we look at this, this is a shelf life chart. So we have percent moisture up on top, and we have grain temperature on the left-hand side. So here's our two figures from the last slide right here, 15.5 and 50, and 22 and 60. So you can see what we want to do is we want to get into this upper left corner so we can have more shelf life, more storage time on that grain. Let's just say, for example, we came in with 24% moisture corn at 65 degrees, a pretty good field temp. But look, we have 6 days of shelf life, of storage time on that grain. So we have to get that temperature and the moisture down into an acceptable range. So when we look back at our two key points in maintaining long-term grain quality, we don't have to worry about air following the path of least resistance. We handled that with the spreader. So now we have to look at controlling the temperature of all the grain in the bin. How do we do that? The Bullseye Controller. So the Bullseye runs off of equilibrium moisture content, and it is a reading in the controller, not a setting. So what is EMC? EMC is basically a measurement of the relative humidity and temperature outside the bin. Basically, that relative humidity and temperature is going to equalize grain to a certain percent moisture, and this is different for different grain types. So let's just say we had 90 degrees and 46% humidity, and we constantly exposed yellow corn to those two conditions. That means that EMC, the yellow corn, would then equalize to 9.9% with those if those two conditions remain constant. Soybeans at 7%. So alternatively, if we had 55 degrees and 72% humidity, if we constantly expose that yellow corn kernel to those conditions, it would eventually equalize to 15.4%. Soybeans, 13.5%. So EMC, we have to look at what we can do with that. Is we can't control Mother Nature, but we can basically take that measurement, that calculation, or that EMC calculation, and utilize that to run when we need to do. We can pick that favorable weather. We can't control Mother Nature. Anytime somebody figures out how to control Mother Nature, they're going to be very wealthy. But we can pick that favorable weather, that favorable range of weather, when we're trying to do whatever we're trying to do with that grain, whether we're drying, moisturizing, or just aerating. So when we pick that moisture window, we're going to cut the extremes off the top and the bottom. Remember how we talked about humidity? Too much or excess humidity can cause too much moisture buildup, can cause molding problems, and too little can cause too much shrink. So we've got to cut the extremes off the top and the bottom. Remember, storing grain is a function of moisture and temperature, so we have to limit the extremes on the temperature as well. The other thing the controller factors in is that when that EMC air, when it goes through the fan, it's going to dehumidify a little bit, warm up from the friction of the fan blades, but also change when it hits that warmer or colder mass of grain. So we have corrected equilibrium moisture content, basically saying that when that EMC air goes through the fan and hits that grain mass, it's going to change. It's going to be different from what EMC is. So CEMC is a more accurate value of EMC. And once again, that's a reading and not a setting on the controller. So this fan warming effect, how does that factor in to what we're doing with our grain? So these are our EMC, CEMC calculators, just a couple examples of what we're dealing with. So in the soybean example, we have air temperature at 50, humidity at 70%. So that makes an EMC of 13.2. So you notice on this first one, our number one grain sensor is 50 degrees, the same as our air temperature. So CEMC is no different. But as we go into just a 1 degree increase in fan warming, and you look at fan warming, basically for every 10 horsepower of fan power, we're going to increase that temperature by 1 degree. So in this situation, let's just say it's a 10 horsepower fan since it's increasing at 1 degree. So our number one grain sensor is 51 degrees. Okay? Our EMC was 13.2. Now it drops down to 12.3. In the next situation, 3 degrees of fan warming, we go from 13.2 to 10.9. This could happen just during the cool down process. If we don't take advantage of what we know about fan warming, we could think we could be putting 13.2. We're actually putting 10.9% moisture air in there. So really with the controller, what we're doing is we're managing that shrink, keeping that grain at market moisture, especially during storage mode. We're also saving energy because we only run the fans when we need to. We can monitor and control those bins from anywhere with AD-Link, and we're saving gas when we're operating low-temp burners. So this is, again, what the Bullseye does is basically cuts the extremes off the top and the bottom. The blue line running through here is going to be EMC. So anytime that line is inside our window right here, which is the green shaded area, that's when we're going to get our fan runtime. So jumping into storage mode. Basically in storage mode, what we want to say is our current moisture and our target moisture are the same. So in this case, we wanted 15.5% yellow corn. We have 15.5 yellow corn. What we're telling the controller to do is basically keep the quality the same, only monitor the temperature. So we make these settings. Current moisture, target moisture are the same. Plus or minus moisture goes to 2.0 from 0.5 in drying mode. EMC limit does not factor in, and we change our target temperature and our maximum air temperature for different times of the year. So how does this factor in? When the controller is looking at our temperature, it averages all of the sensors that are X'd or checked on AD-Link, and anytime that average in storage mode gets out of that range of in this case, 45 degrees plus or minus 5 degrees, so between 40 and 50, if it gets outside of that range, the controller is going to want to run. The first thing it's going to do is look at our minimum and maximum air temp, so between 30 and 60 degrees in this situation. So if we're within that range, it will then look at our window. Are we between 17.5 and 13.5? Then the controller is going to run. So basically, you can have the possibility, as long as all your temperatures are okay, you're going to get very limited runtime. This is just another way to look at it with some even numbers. So in this case, we're saying our current moisture is 15, our target moisture is 15. So we're saying we have what we want for quality, maintain that temperature. So this sets up our storage mode moisture window with our plus or minus moisture. So what that does, our top is then our target moisture plus 2, our plus or minus, is 17. Our bottom is 13, our target moisture minus 2.0. We're then under direction of our minimum and maximum air temp, which for good fall storage is 30 and 60. So it will only run when our air temperature is between that 30 and 60 degree mark. We then have our target temperature set at 45 with a plus or minus of 5 for fall storage. So what we're doing there is we're looking at keeping our sensors between 40 and 50. All of the sensors that are X'd are factored into the programming at this point. So these suggested settings are all set up on the controller. The biggest thing we need to look at is the seasonal changes for maximum air temp and target temperature. So as we look, during drying mode, we want a wide enough temperature range, so if we need to run, we get that opportunity to run. So we set our maximum air temp at 90. As we get into storage mode, we want to make that maximum air temp at different levels, because basically what we're trying to do, like we talked about before, is we're trying to maintain a temperature inside the bin that's easily sustainable with the outside air conditions. So we then adjust our target temp according to different times of the year as well. So, it's really hard to keep 35-degree grain in the middle of the summer. That's where we have our moisture migration and condensation problems. But it's also really hard to keep 55-degree grain in the middle of the winter. So we have to change those different temperatures as we go through the different seasons. So it's really simple now with AgriDry. What we can do, and I'll just bring up an AgriDry page. We'll get home. This is how you guys log into AD, and anybody that has AgriDry is fairly familiar with something like this. So let's just jump into a controller here. Okay, so this is the first page you're going to see, and it's basically just a snapshot of what's going on, all the pertinent information. Here's your temp cable right here. So if you have multiple temp cables, they would all be listed in a row. This customer only has one, and then all the different pertinent information is up here. So let's just quickly go into our device settings, because hopefully you're familiar with all the small details that are associated with AgriDry. All right, this customer is set up in a storage mode, so let's just set it back up in natural air drying mode. And that's the new wizard, guys, right there. If you see that, you can basically make 6 different questions, or answer 6 different questions, and it'll make all the major changes for you. So I just set this controller up for natural air drying, change my maximum air temp to 90, current moisture to 18, target moisture to 15. So after I pulled my samples, made my small changes, got to, let's just say, 15% yellow corn, I'm going to click onto the storage mode button. We'll then go into, let's say, spring and fall for a season. I want 15%, update, OK. It then changes all of my settings into that fall storage mode. So our maximum air temp went to 60 degrees. Our current moisture and our target moisture are the same. Our moisture difference, or the plus or minus moisture on the controller, went from 0.5 to 2.0. Remember, moisture limit, EMC limit, does not factor into storage mode. It also changed our target temperature to 45 degrees. Now, this does not go to the controller only if we were to hit save and apply. So it won't apply to the controller until we hit that button. And let's not do that right now. So as I go through the seasonal changes, let's say I was coming into winter, and it all just kind of depends on a trend. We have to look for a good, solid 10-day temperature trend and a forecast where it's going to continue that way. Usually a good time to look at changing into winter storage is going to be right around that Thanksgiving time. But like I said, it just depends on every controller, every area, and different regions. It's a good thing to call the office and ask for tech support, or call your regional AgriDry representative. They can basically give you an idea of what you're really looking for. But like I said, a good solid 10-day trend and a continuing forecast in that range. So when we go into winter storage, we click Update, OK. It then changed our maximum air temp to that 40-degree mark, and then changed our target temperature from that 45 degrees to 35. And then continuing on, if we wanted to go back into spring, it would change our maximum air temp back to 60. and our target temperature to 45. And then finally into summer. It then changed our maximum air temp to 70 and our target temperature to 55. So fairly simple, especially with AD-Link and the Wizard. AgriDry is available for retrofits on your current controllers. Give your regional AgriDry representative a call or the office at 1-855-AgriDry. Just quick to mention, this is a good time to be thinking about the AgriDry Enhanced Service Agreement, as well as your checks for this year, your pre-harvest checks to make sure the equipment's up and running. These are a great deal. Gives you an opportunity to have one courtesy stop during the year by an AgriDry service rep to do any preventative equipment check and correct operation and answer any questions that you have during this time. Also, it gives you an eligibility for a 5% discount off of new equipment or upgrades to existing equipment. And it is a step-up plan. So if you have multiple units on your bin site, we aren't going to charge you that initial charge on all of them. It's going to be a reduction on each one. But the great thing about the controller plans is it does include 1 full year of an AD-Link subscription included in that controller plan. So we talked a lot of things today, just kind of quickly brushed over some of the topics that we discussed in the customer training seminars. Those of you who have been involved with that across the country have heard me talk a lot more in depth about this stuff. Please join those when those are in your area. But basically what we focused on is a little bit of the high moisture area caused by moisture migration, a big core of fines in the center. Basically, air always follows the path of least resistance. That's one thing you remember from this webinar today. Please do that. Air always follows the path of least resistance. So we get that non-uniform airflow going around that core, hot spots in the middle, non-uniform MC all the way up. We try to core that out. Air follows the path of least resistance again, goes straight up the center. We're still getting those potential hot spots on the outside, non-uniform moisture content. And so what we're really looking to do with the spreader and the controller is to get that good uniform airflow, spreading all those fines out with the grain, not having to core, not having to blend, not having to feed that off, whatever we're doing with it, but getting that good even temperature, taking the guesswork out of running the fans, getting everything right where we want to be. Because you've got to look at there's still a lot of money in those bins. Even with prices the way they are today, there's still a lot of money inside those grain bins. We don't want to back into a problem or drive headlong into a situation. We need to really focus on where we're going and what we need to do. Here at AgriDry, we are the grain quality control solutions experts. Any questions you guys have at any time, please dial 1-855-AgriDry or contact your regional AgriDry representative. And continue to follow this webinar series in the future. Thanks everybody for your time today. I greatly appreciate it. Any questions, please don't hesitate to call us.